Hey guys, this is 1.6 notes. We're broken into 2 days for 1.6. This one is on parent functions. So we're going to learn 12 parent functions. There's more than 12. Um, Next year in calculus, if you guys are lucky enough to take it, whether it's here or away at college, you guys will need to be familiar with all these parent functions. And we'll learn that most of the functions we study the rest of the year are either exactly these functions or some transformation of these functions. Okay, so there's 12 examples. I'm not going to go through all of them. I can show you all the graphs, but at some point it just kind of gets a little bit redundant, and most of you could probably go ahead and do um, this note session without even watching this video. So I don't want to waste your time, but I do want to make sure that I can at least go over enough so that you feel comfortable completing this. Okay, so let's see. The first one is f of x equals c. This one's kind of tricky. Really, it just, remember f of x is y. So this is really just y equals any constant. C stands for constant. So I'm going to choose y equals 2. You pick what you want. Okay. Um, so I have all these graphs on Desmos. There's 12 equations that I've plugged in. If you're not familiar with Desmos, it's just desmos.com, and you can do the graphing calculator. And then just by clicking this circle in front, you can choose whether to, show those graphs or not. So we can toggle them on and off. So the first graph, y equals c, f of x equals c. Um, it's just a horizontal line, right, at whatever your c value is. So for me, I'm going to call this C, and it's just a horizontal line. So my domain, my x values, it's all real numbers, right? Range is only one value. If you pick 2, then 2 is the only value in your range. If you pick C, let's just call it C, and I believe that we just put that number in a bracket, and since it's only one value, that's all you use. If I'm wrong, then let me know. But I believe that's it. So for x-intercepts, unless we pick 0 for our constant, there are going to be no x-intercepts. So let's assume that we're not picking 0 for the constant, because y equals 0 would simply be on the x-axis, and it would have an infinite number of x-intercepts. So let's say none. And then the y-intercept is going to be 0, comma, whatever you picked for your c value. Okay. Okay, y equals x. Remember, that's like y equals, if we're thinking slope-intercept form, y equals mx plus b. It's really y equals 1x plus 0, right? So y-intercept of 0, slope of 1 over 1. So a lot of us don't think about that, but this is just going to be diagonal line cutting through quadrants 1 and 4. I'm sorry, 1 and 3. So domain, negative infinity to positive infinity. Range is the same. X-intercept 0, 0, y-intercept is 0, 0. All right, moving along. Y equals x squared, by the way, even function. We know what that looks like. Y equals x to the third is the next one, odd function. We know what that means. So I'm not going to fill those in, but let's go to ln x. So this is the natural log of x, or you could say ln of x. I believe you learned logs last year, but it might have been once we were learning at home, so it might not have been the smoothest learning experience for you, but let's see, ln of x. So I love Desmos because you can just tap on these points and it gives you a nice intercept. So it looks like x-intercept of 1, 0. So natural log of x. X-intercept of 1, 0. And then it kind of comes out like that and approaches the y-axis. So some of these are hard. Like it's hard to tell if this actually crosses the y-axis to have a y-intercept. So what I would recommend that you do at your y-intercept, your x value is 0, so your input is 0. So why don't you just go ahead and type in natural log of 0 on the calculator, and you'll see that it gives you a domain error because it is actually not part of your domain. So natural log of 0, yeah, it's giving me an error. So that means that 0 is not included in the domain. That also means that there's no y-intercept because it'll be 0, comma, a value. So domain, it looks like I'm not including 0, but I include everything to the right. The range value, this is clearly heading all the way down towards negative infinity, and we can see as I move out to the right, I'm increasing and getting higher and higher values. So that would be all real numbers. X-intercept we said was 1, 0, and no y-intercept. Okay, now let's do e to the x. We'll learn later in the year, these are actually inverses of each other, which means that they are reflected over that line y equals x. We already talked about y equals x, right? So these are reflections over that diagonal line y equals x, and they are inverses of each other. So y equals e to the x. Looks like this one has a y-intercept of 0, 1. And it kind of rides the x-axis out to the left. This is never going to hit the x-axis, and you can check on a table, and just if you scroll up on the table, that'll take you to lower and lower x values, or further and further left on the graph, and you'll see that those outputs, the y values, are going to get really, really small, but they're never going to hit 0. They'll never be negative. So what that means is, let's see, domain, negative infinity to positive infinity. The range, we just said it's never going to hit 0, but it looks like it will go as high as positive infinity. X-intercepts are none. Y-intercept is 0, comma 1. When you list your y-intercept, don't just write 1. 1's a number. 0, comma 1 is a specific point on a graph. Okay, so be better than just writing 1. That's a good motivation right there. Okay, f of x equals 1 over x. There's a few more here. The one thing I wanted to talk about here, so this is a little goofy looking, right? I have two branches that look like they're kind of mirrored over a different diagonal line. But to me, this looks like an odd function. And I just want to, this isn't necessarily part of these notes, but another way to write 1 over x, that's like 1 over x to the first. That's the same thing as x to the negative first. So properties of exponents, you can bring a term from the bottom of the fraction to the top if you switch the sign on its exponent. So 1 over x to the positive 1 is the same as x to the negative 1. And once we're in that form, examine all of the exponents. The only one I show is odd, so that's an odd function, which means it should have rotational symmetry, which this one looks like it does, right? If we put a spinner at the origin, spin it 180 degrees, it should look exactly the same as it does. So that's just kind of an interesting note on this one that I wanted to point out. Another point on this, you can see it looks like I have a vertical asymptote at x equals 0, and that should make sense because if I plug in 0 to 1 over x, I get 1 over 0, and that's undefined. So that means that 0 as an x value is not allowed in your domain. So let's see, something like that, something like that. Domain, so how would we write that? It goes from negative infinity up to 0, parenthesis means I remove, but then I continue right after 0 and go to positive infinity. Range looks like it's going to be the same, right? If I go all the way to the left and all the way to the right, and again, you can verify that on a table, you're never going to hit 0. The left part here will approach 0 from the negative side, but never hit 0 or turn positive. And on the right side, it'll get smaller and smaller and approach 0 from the positive side, but it'll never hit 0. So the range should be from negative infinity, right? My lowest value down here. It approaches 0, doesn't hit it, but then I pick back up over here just above 0 and I go as high as positive infinity. And then I have no intercepts, which should make sense, right? If you don't have 0 as part of your domain or part of your range, then how would you have any intercepts? Okay, let's talk about sine of x, and this may be the last one that we talk about because cosine is very similar. Oh, I didn't put sine of x in. Let's do that. Sine of x and radian mode. Okay, we like to be in radian mode when we talk with trig functions. Okay, so this looks like all the way to the left, all the way to the right. I have an intercept at 0, 0, a y-intercept at 0, 0. So let's sketch this real quick. Intercept, I go up, and down, then up, over here. It would look something like that. Okay, so domain very clearly is negative infinity to positive infinity. Okay, my range looks like the height up at the top here is 1, and the height down here is negative 1, including those values, right? So it should be negative 1 to positive 1 because there's every value in between. Those should both be brackets. Okay, let's go y-intercepts first. Remember, you can only have one y-intercept if it's a function, so that's 0, comma 0. X-intercepts will get a little messy because this is pretty interesting. How many x-intercepts do I have? Well, holy cow, I have 3 to the right here. Looks like I have 1, 2, 3. But if I scroll over to the left, look, that's like an infinite number of intercepts, right? So how do we write this? Let's highlight just the x-intercepts. It looks like the x values are 0, pi, 2 pi. You can guess what the next one is, 3 pi, 4 pi. So I keep adding pi, and I can add that an infinite number of times, right? Because it's going to go forever in either direction. So the way we can express that, so I know that my first one is 0, 0. Then I have, what was it, pi, 0, then 2 pi, 0. So obviously we're not going to list all of these out. Some teachers may want you just to write like 1 or 2, or write all of them between 0 and 2 pi, which we would have those covered. I would say let's account for all of them by writing like this. It's always comma 0, and then if you're increasing by pi every time, we can say n pi comma 0, and this is for all values of n, okay? I should say for all integer values of n. So that means n could be 1, that's pi 0. N could be 2, that's 2 pi 0. If n is 15, it's 15 pi 0, right? So that kind of covers all of them. So what I would write is, what did I do there? I would say n pi comma 0, and we would assume that n can be any integer value. Okay, so cosine is going to be similar. Check out the answer key if you're struggling with that, and I think that you guys should be good with the rest of them. By the way, one note on this, 1 over x squared is going to be the same as x to the negative second, so you can guess that that's going to be symmetrical over the y-axis because it's an even function. Okay, thanks for watching, guys.